G'day guys. Said I was going to get this 5000 done, and yeah, it's 9:15 at night. Been on it all day, and just fine tuning and just trying new parts, anything that would get some more performance out of it. So anyway, I've got it sitting there at the moment. It's running flat out full gain, and if you have a look on the oscilloscope, you can have a look here. I'll point a few things out. I'll just zoom in. I'm using the right camera this time, so I can just lock that so it doesn't spin around. I'll touch it. So you can see that there. This is the amount of noise in the workshop. I'll just make this probably a bit bigger and a bit brighter. You see the bottom trace, all those little vertical lines? That's all 50 hertz interference, and that's crawling all over the signals going into this detector. That's actually that's a transmit. They're on normal mode. But if you notice one thing, have a look at the time, microseconds. We got this running at 26 microseconds on the TX pulse on normal mode, which is pretty fast. And this is the speed that stuffs up the fine gold mode on these detectors. If you crank the gain up too far and put it into fine gold. But even though that's our reference there, 26 microseconds, I'll just stick this into fine gold. And it's in fine gold, and can't see anything on the screen because I've probably got it spread out too far. It'll go to pot doing that. I'll take it off zoom and bring it back in. Anyway, we're on fine gold mode, and if we have a look at some of the very, very small transmit pulses there, we'll just bring that up. I'll bring that in, and a very small one there, get right on it. That's right in now. Yeah, it's about, that one there's about 10 microseconds long or so, but we'll get onto the receiver in a minute. Just have to change channels to plonk it onto the receiver. But yeah, there's heaps and heaps of 50 hertz ripple on that. You can see that as well. And it's just totally a bit of a bucket of noise in here. To give you an idea, I'll just change this. This is running full gain, by the way. It's full, everything's flat out. And we'll get onto the coil and ground balancing part of it in a minute. But just for interest, we'll stick that there. That is one of the receive lines on the detector. Now you watch what happens. I'll just put my soldering iron on, right? This is what you have to put up with. Okay, let's see what happens to that. As it turns on and off, it should go all over the place. You can't, it's pretty hard to see, but it is bouncing around at the top there. But I'll spread it out a bit. Yeah, see that there? That's actually 50 hertz. The whole thing's up and down like a yo-yo. And yep, you can see it beat the beat frequency there. See the waveform? It's meant to be still. It's not meant to be going up and down like that. If you can see that, I don't know if you can see it, but it's jumping around all over. Oh, there you go. Look at it as the soldering iron turns on and off. I might alter the frequency a little bit. There you go. I don't know if you can see it doing that. Maybe the camera doesn't capture that very good, but it's absolutely tons of 50 hertz getting into this detector, and you say it's running flat out. So Now I'll put the frequency back up. That's running as fast as we can get it. Let's put it in. I'll zoom back out. Oh, what a job. Anyway, as you can see, we are in fine gold. It's just standard on the back menu, special fine. So let's go up. Like I say, this I'll give you a look. I've got the variable gain on it, so we'll just turn. There you go. That's a variable gain all the way off. It's still pick up targets, no problem. But it is put it flat out. So it's in fine gold, cranked to the max with a slow sluggy double D coil on it. But I'll just zip this up in the air. And this is the bit you want to see. I'm going to do multiple hands here. I don't want everything to fall over. Hang on a sec. It's got to go around there. There we go. We'll get up to the coil. Somewhere up there. Here it is. Okay, I'll just lock that there. Don't fall. Stay there. Oops. And maybe there. Okay, up there I have this. This is the biggest problem with fine gold. When you crank it up in frequency and clock it faster than normal, especially at very high gains, but it will carry on like a pork chop until I just shove it into, get under here, and I'll put it into fast track. Yeah, it's just riding in the noise. There you go. That problem is cured. And a double D is a slug of a coil. So on a really fast mono, it would be a hell of a lot better. So, yeah, that's how it works. And because I've got a lot of noise, I'll just use the 0.05 grammer, that little spec there. I'll just turn the amp up a bit because it is down. But there is a lot of, like I say, this is running more gain than probably any detector's ever had in its life, believe me. And still be able to grand balance. It's very, very unique. Gonna get lost in the noise because we really want to be out in the middle of nowhere doing this. And yeah, now I'll turn my soldering iron off. It makes a hell of a racket as well. There we go. Yeah, it's going to get lost in the noise. But even if I turn the gain down, it retains a hell of a lot of depth. On a 0.1. I think it's getting swamped with noise at the moment. I'll turn the gain down a bit. I had the gain way up too far, even though still running very, very high clocking rates. I might actually trim the gain back a little bit because it is just too much gain. I know what's going to happen. People are going to crank it all the way up with a bad coil and it'll desensitize. So I'll probably take that out of the equation just by scaling the gain. So I've probably got to do a little bit of an adjustment there, just change a couple of resistor values just to scale it properly. But this is not the best coil to put it on. not at all, especially double D, doing these high frequency, high gain things. If I put a mono on there, it absolutely, I mean, in here, I really can't, but, you know, 0.1. That's massively reduced gain, also in cancel mode. Well, if I turn if they turn the gain down to 0, and I'll put in the mono. Okay, we're in mono now. So, but the noise, you can hear the noise, even on a gain of 1, just the way it is. So I just use the test target. Like no gain. It's just swamping out the front end. But, you know, you want to use something decent, a decent sized target. Like I say, that's in fine gold too. Use a ring, you know. That's on a gain of 1. And it's way up in the air, so let's put it back into normal mode. So normal mode, reduce gain. Well, you can't see right at the top there because I'm too zoomed in. But it's picking up real well. That's on a gain of nothing, no gain, because I'm running it in mono mode. How do we get around this? That's the trouble with, you can do so much development work in your workshop, for sure. But you've got to get out in the field to test everything, because there's no way known you can get the gain out of it in the workshop as you would do out in the gold field. So let me have a look here what I've got. Okay, I'll try and get a small coil here, a small one. Here we go. Look, it's an old Super Gold Search mono, but you know, it is a smaller coil mono. We'll try it anyway. Probably pick up just as much noise. I should turn the workbench off, but then the lights go off and makes everything hard to see. But people wanted to see this, so turn him on. We'll see how it goes. Okay. I might actually have to do up the connector. There we go. Done the connector up. The other thing too with these, it probably doesn't want to pick up its own cable, but the cable's really thick on that, so anyway. There. Can I zoom out? No. Doesn't like me touching the camera. Yeah, the camera's interfering. So, look at that, just touch the camera. It's picking up the tripod. And that's on a gain of 0. So we can get a lot higher than that. That's running a mono inside the place. So it's, I'll just put it in the fine gold. So it's in fine gold. Yeah, not really a good idea having the detector. We'll go down again. There you go. Picked up the camera. There we go. I've got to get a... There's a lot of interaction going on at the moment. See. I'll take the oscilloscope lead out. Yeah, it's all a little bit touchy because it's out of its box. But yeah, I'm causing interaction, move my hands around. But inside, it's nice and stable. It's just all the interaction with stray fields getting into various things. So, but yeah, that's it there. What I'll do, yeah, stick it into cancel with a mono on it. That'll fix it up. So, but there you go. That's flat out audio. So yeah, it sounds like it's cancelling itself pretty well at the moment. Oh, turn it off. But that is about 90% done, and like rechipped, new front end, new MOSFETs all round, different types of MOSFETs. Yeah, a lot of things have been changed in this detector, and like I say, I've just roughly put it together. Oh, dear me. God, it's hard to work. And yeah, it's been basically rechipped on the top, rechipped on the bottom, and the new boards are in there. So there's 2 complete new front ends and a VGA amplifier. Everything's been scaled so that it should work perfectly on a mono coil. And as soon as you put these older double Ds, they've got a lot of capacitance in the coil, and that can force you to either lower the clocking frequency or lower the gain. I always say with these detectors, when you are pushing the limits, and these are why I don't really want to just put these out for the general public, because if you're not knowledgeable and understand that if you just crank everything flat out and put a lousy old coil on it, that things may not operate as you expect them to. You may have to reduce gain, reduce frequency, or both. It depends on the coil. But I've run this on the more modern coils. Even look, what I'm saying when I say modern is we look at Nugget Finder Advantage coils, 12, 14 inch, 16 inch coils, and it runs beautifully. It is absolutely fantastic because they are a fairly low capacitance coil, and you can clock them fast. As soon as you start having a coil that has high capacitance in its winding spacing or dielectric or whatever, or even bad cable with high capacitance, you can't clock them fast because it just will not remove all the flyback, and it gets into the receiver and desensitizes. So you really got to know the detector if you want a detector like this. Like I say, this has taken me hours and hours and hours, like probably 2 full days, and then some to do this. Actually, 17, 18, 19, 20, 21, 22 hours. 22 hours on this one. And like I say, there is a lot of work that went into it. It's not just putting the parts in, it's taking the parts off, the old parts. Yeah, it can be fraught with danger. You have to be very, very careful because everything's glued onto the board, and you think that it's glue, and if you pull it too quick, you'll rip the tracks off. You've got to make sure that everything, all the legs are heated up enough, and then you crack that glue. If you do it the wrong way around, you can cause yourself a disaster. So that is the 5000 done, and I'll tell you what, this thing is absolutely cranking. It is absolutely just going completely nuts cranked. So what I can do is one last test with that. Even that's not the best coil to do it with. I do have a Nugget Finder 12, but they're starting it to the size where it just picks up too much electrical interference, because doing it in the house and trying to do it in the mono, it's very difficult. But I'll give you an idea anyway. I'll turn this thing back on. I'll just turn the volume down because it's going to be deafening. God. Okay. We'll try, it's in fine gold, okay? And we'll put it into mono. Okay, she's in mono because I've got a mono on it, right? And it's going to make this horrible noise, right? But the frequency is full bore. Let's see, let's crank it up all the way. It's going to be absolutely horrible, but I want to see. Right, like I say, it's going to go completely bonkers. I don't know if I can even get any of that out. No, this is ridiculous. This is like starting up a Harley Davidson in your bloody lounge room. But just to prove it works really well for mono, even everything cranked up. See if we get rid of the hot rock. Hang on. Fix tracking. Here we go. It got rid of the hot rock. It's just riding the noise. I'll give it one more flick. Just to prove the point. It's going to scream like crazy. Out in the field, it'll be dead quiet. It will not do that unless you're near overhead power lines. You won't be able to hear it through the noise. Get me onto the game pot. Get me out. Oh, like I was saying, that's just a fool's errand. Running that much gain with a mono inside the house in fine gold, which is an absolute monster of a mode to use anyway. So fine gold, that's a gain of 0. Yeah, gain of 0, no problem on that ring. Let's go into normal timings. Over the top of the ruler, easy. So this is an absolute kicking detector. It is absolutely a little powerhouse. But back to the detector. Yeah, so running a mono in the house, and yeah, if we want to make it be quiet, we just stick that to cancel and shut it up. But yeah, it's an absolute doozy. So that is it. I'm going to just clean it up and do the proper gain scaling to make sure that just 100. See, you saw then on a mono, it doesn't saturate. It doesn't have any problem whatsoever, even though it's not a very good mono. And the only thing I have worry about is people use very big old coils, and that's when you possibly, if you use fine gold with a huge great whopping coil, with everything cranked up, you're asking for trouble. It may desensitize. So that's what I'm saying. You've got to know what you're doing to have one of these super modified detectors. You can't just go and, get it and go running around saying she'll be right, mate. It won't work that way. I've even had what I would classify as professional prospectors get into trouble because they just try and push it too far. It's going to push way past the normal detector, but you can't push it, um, you know, so far that it's like putting slicks on and driving it in the wet. It's not going to work. You're not going to have any traction. So same sort of thing. But like I say, it is pushed. This is pushed to the max. The front end is super low noise. It's probably the lowest noise figure front end I've ever done, and the amount of gain is absolutely horrendous. No, it's a hell of a lot of gain there. At the back end here, it's sitting at factory default gain settings. Everything's factory default except for the frequency. And also, like with the frequency like that, it's made for very, very tiny, tiny gold. And if you lower the frequency down, you'll then optimize those pulse widths to get uh, more energy into bigger targets. A bigger target, you got to look at a target like a bucket, right? And your energy is the water. And you got a small bucket, you only need a little bit of energy to fill it. You got a great big bucket, you need more energy to fill it. So more water, basically a longer time duration on the transmit pulse. And yeah, you'll get more water flow into your bucket. I don't know how else to explain it without getting technical, but basically, I've said before, it's like a big target's like a big bell, and if you tap that bell with say, for instance, the back of a toothbrush, it's not going to ring very loud, even though it's a big, big target, big, big bell. So what you need is more energy. And when you start putting more energy on a big target like that, as in lowering the frequency, that's equivalent to hitting the bell with larger and larger hammers. So then the output energy from the bell, the return signal from being hit, is a hell of a lot easier to hear. And same with the detector. You start get a 1 kilo nugget, you're not going to go and just tap it with the back of a toothbrush. You need to really slam into it to get that return signal. I'm speaking like electrically, not go and hit the hammer, but your electronic hammer needs big, long pulses to be able to energize big, deep targets. So it works out well for these detectors as well, because also it scales the off time, which is the resting time between the transmitting and the receiving. And on those lower frequencies with bigger targets, you can extend the dead time out because it's such a big target. You can allow more dead time for the ground to decay and become very quiet before the receiver turns on. And you've got a far better chance of hearing those big ones at depth without having any sort of ground noise or chatter coming in, anything mixing. Even if the ground decay, you can get an EMI signal will mix with that decay rate and cause interference. There's all sorts of funny mixing stuff goes on in these detectors. They even generate their own interference. So this one is an absolute ball terror. I've tested this against the 4500. Actually, I've got a standard 5 sitting down there. I can go and test it against that. But trust me, it's not going to go like that. It's no way known it's going to have that much punch. So this is, I would call the bee's knees detector, and I'm pretty sure, because I've played with a lot of 6000s, and this for very, very tiny targets was showing extreme sensitivity. Because the 6000 is so damn noisy, if I do it in here, I can't hear the target. No, I can't hear those targets. You have to rub it on the coil. And yeah, just even from the outside testing I've done, I think it actually does exceed the performance of the 6 on target recovery. But then again, it needs to go out in the field and be tested. So that is what's coming up. I will probably try and knock this one over maybe tomorrow morning and see if I can get out tomorrow, Arvo, and do some testing out in the goldfields. We'll just see how I go. So, anything else I can add to that? Not really. I just want to do my input wiring from the coil to the board a bit differently. What else is there? I've got to clean up the board. It's got a lot of flux residue and stuff like that on the board. But apart from that, it measures really well. It looks really good, and yeah, it exhibits all the characteristics that I would expect from a really, really good one-off engineered metal detector, like no expense spared type detector. Instead of buying a $5 part, you go and buy a $50 part, that sort of thing. This thing is over the top, basically, as a as a normal gold detector. Is just super punchy, and yeah, I'm absolutely I'm over the moon with this one. It's actually the way I've done this is different than the 45. 45 was a bit more well behaved, but this thing here is a bucking bronco. This thing here, but see, the thing is, I did that on purpose because it's so difficult to get fine gold to work with a lot of gain and clocking the hell out of it when it's got very, very small receive windows on it as well. I don't know what they're actually down to. I think last time we looked at them, they were around 4.8 for the small pulse. This one here, it may be down about 4.5 maybe. I will have to check that, but it does perform, it does work, it turns on, doesn't desensitize, balances out hot rocks all the way. That is very unheard of, doing it at that sensitivity level and that transmit receive clocking rate. That is extremely fast. That'll pick up pinheads easy as. It'll really, really scream on very, very tiny targets if you want it to, or just lower the frequency. And basically, if these things, so you put it up, say, around 240 to 255, whatever it goes to, up around the top end there, and use that for very, very tiny gold. And then if you want to do general prospecting, I usually crank it back somewhere. Usually myself, I'll run it about in the 180 to 220, somewhere around there. And then if I put a really big coil on it, I want to go for big, deep stuff and run a lot of grunt, I'll even turn it all the way down to 1. And in normal mode, dropping the variable frequency to 1, that's a massive long pulse. We're talking pulses going from 26 microseconds probably to about 40, 42 or 43 or something, even 44. Depends how I've got the scaling done on that. But I try and do it in a way that around 128, 130 is exactly the same as what a normal Minelab does. Puts out the pulse length, the short pulse length in normal timings at around about 35 microseconds. So you got a huge range all the way down to 26 from 35 and all the way up to about 42 from 35. So as a percentage, you work that out as a percentage and it makes a big difference. The gain is far in excess of what you get out of any detector. Like I say, I could even try turning the back gain up to 20, running the front end gain up to full bore, and trying it and see if it actually can get rid of hot rocks. Actually, I think it will, because the area where it has been worked on is specific for the detector to be able to get rid of super hot rocks. And those Kalgoorlie things are absolute nightmares. I've never, ever had hot rocks worse, except for my big tray of pure ironstone, which is basically little balls of Kalgoorlie hot rocks, more or less, but it does come from Great Western. And they are really reactive as well. And Yeah, I think someone said something about that on one of the comments. They were amazed that it could actually do it, detect through that in ground balance, which really amazed me as well. And that was a 45. So maybe what I do, so I've done 145, I've got another 45 to do, I've done this. If I prove this out perfectly, I'll do the other 5,000s, and we will have something very special in the way of a standard, no nonsense pulse induction detector with lots of fiddlies on it. That's what I mean. It's not a quick and easy, just push the button away you go, but you can just bang it to factory default settings and just adjust the gain, uh, and that'll work just as well. That's how I do it actually. I don't worry about fiddling with the back menu. I leave stabilizer on 10, signal 17, all that stuff I leave standard, and there's a reason I do that, because the guys who made this detector would have mucked around with all those settings for probably months, and they've worked out the best settings, and that's what its factory default is. You know, it's everything's working really well. You know, some people will get the stabilizer and they'll go, "Oh, I'll put a stabilizer on 20." Well, it's just a noisy bucket of bolts. Um, or get the stabilizer and stick it on one, and you'll lose all your small targets. Just leave it in the middle. You know, you think a lot of people think that they're, doing all the fine tuning. You know, sometimes it's detrimental. It may be good for one particular target size in a particular type of ground with a particular size coil, but you're probably suffering in other areas of detection. So it's horses for courses. You know, a lot of you guys have been doing this for years and years and years. You know what you're doing. It's just that my way of doing it, I tend to leave the back menu settings standard. The only thing I do adjust is the tuning, because that is now the variable frequency, and the front end gain. So normally I just get the gain up to a level where it's fairly high. You can use the back menu gain to move the gain up and down. It does a good job. It's good because you can't stuff it up. A newbie could get it and will not do anything to make the detector not work correctly. But doing this, what I've done, it does require a little bit of knowledge that don't use a crappy coil for a start, because that just makes life hard. You can turn the frequency down, of course, and use a crappy coil, and probably turn the gain down a little bit, or either or both, like I say. You can. There's nothing wrong. You can get an old dustbin lid from 1995 or whatever, 96, and stick it on and adjust it. It'll work fine. It'll compensate and work for that. No worries. But just don't go and try and use your 18-inch dustbin lid to pick up pinheads, because that is just crazy. You can set it so it will do that, but it defeats the purpose. You've got a big coil on looking for big targets. Don't go looking for pinheads. You'll spend all day trying to find it too. Yeah, okay, that's enough of a waffle. Yeah, so all good, and yeah, that's it. Now, when it's back together with the box on and properly earthed out and grounded and everything else, they're a hell of a lot better and more stable. But I've got this on the bench. It's picking up tons of 50 hertz interference. It's getting into everything. But what I need to do is, yeah, basically put the lid on it, put the case back on it, and it will be a lot better. And definitely, I'm not going to go swinging out in the gold fields like that. Yeah, I had bits of detector all over the place. But it definitely has to go back in its box. And yeah, I should, I should go out with two detectors. I should go out to the standard 5 and this and run side by sides. I could even do the 45, but it takes up so much time doing it properly. It takes up, the whole day's gone, doing that. And I've got tons of work on. So it's not holidays for me. I've just got tons of work on. More detectors coming today. So, yeah, so what's come in? 7,000, 2,100, and something else. I don't even know what it is. That's another 5,000. Oh, dear me, good timing. So, yeah, we got 7s, 21, 5, yeah, and yeah, 3 others sitting down there from the other day. So yeah, I've got to get onto it and get through this, but you'll see if I can. Yeah, you know, I'm going to get to the point where I'm going to probably need a professional tester to work side by side with me, like someone who is prepared to test detectors, someone uh, basically not aligned, just autonomous, uh, test detectors and make videos. Make good records and a log of how things worked. And then we can just optimize and optimize and optimize. So that might be something I should look at in the future, to get someone who's willing, got the time, go and do some really proper testing with these modified detectors. So that's probably the direction we're going. The thing is, if I go out in the field and start testing, I'm not doing any work because it just snowballs on me. So I've got to keep slaving away. But I can go up the local one and do some tests, but even that takes a couple of hours out the day. So yeah, that's a couple of hours I could put into doing these detectors. So that would sort of hopefully clear my work load a little bit, so I can go out and have some fun. I yeah, just 4 walls all the time. Anyway, that is the 5,000, guys. I hope you enjoyed that. And yeah, it's an absolute mind boggler of a screamer. Even running the mono in here like that, that's on low gain, of course. Turn the front end gain down, but it was still on high frequency. And yeah, still cope with it. Balances hot rocks, flat out gain, hot rocks gone. Yeah, even on all modes. I know if it does it in fine gold, it's going to do it in normal. It's definitely going to do it in enhance. So it's no worries there. But the main one is you've got to get the fine gold mode on these to behave. Um, I don't like it myself because it's not a really deep mode if you're looking for big gold, and you're really better off you're better off using normal mode. Believe me, if you've got hot rock control, or basically get hot rocks under control, use normal mode, because that is where all the big gold uh, is. It's obtainable in normal mode. As soon as you go to enhance, same thing. And see, I used to, when I had my first 4500s, I would run around everywhere in enhanced mode because I loved how quiet it was, right? And I didn't have to dig any hot rocks in most cases. And I think back, now I was just being lazy, and I think it was self-defeating doing that to a degree, because you think of the larger targets that if you went over them and they were an extra 30% of what you would what fine gold could get, that's where normal mode comes in. It'll give you that depth extra on a big target, and you're just walking over them. You're not going to go and dig anything, but you won't waste your time digging hot rocks, but you won't waste your time digging up, $250,000 nuggets either. So sometimes it's better to dig the hot rocks, some hot rocks, and go for the big stuff. Even this, I'll tell you right now, even this detector, normal mode, even set on a gain of 1 and drop the frequency back, because the front end is so low noise, it's very, very low noise. I think I'll quickly work it out for you. It's probably around about, normally they're around about 1 nanovolt per hertz. This thing's running at about maybe a little bit under, what would it be? Probably about 0.4. So it's far more low noise than normal detector. And also I've used different MOSFETs in the receive line as well, which MOSFETs are noisy. You look at a MOSFET as a resistor, and also they suffer from gate leakage as well, and gate coupling. Yeah, different topography in the layout, parts, drive, and you can make a whole different beast. And yeah, especially when these things, like I'm not going to get into that now, but remember people were telling me that when you have a mono coil on these detectors, people tend to run it in double D, so it only uses one input channel, doesn't parallel. And I found the reason why that was happening, and that was a pretty straightforward fix-up. And with this now, with the low noise front end, I parallel that in mono again. God, we're getting such a low noise figure, it's getting down to ridiculous, because technically speaking, we should be knocking off probably about another 2.7 dB, which would bring the noise figure probably around about 0.35. So it depends. You know, if you're hooking up to a noise figure meter, and you can't do it for a detector, you've got to do it for a set signal and that, and you look at the noise floor. But yeah, the logic in the calculations there would say that we're getting a very, very low noise figure, very low indeed. So I'm amazed. Out in the field, this should just be dead quiet. It should just be, no noise, unless you crank it right up, of course, in his EMI. And lately too, there's been a lot of solar activity, and solar activity makes your detectors go crazy, by the way, especially if you want to know if it is solar activity. Put your coil edge on to the sun, and if the noise goes down, it'll be solar activity, right? And put your coil flat side to the sun, the noise goes up, it will be solar activity from the sun. All sorts of horrible emissions, radio emissions from the sun will affect detectors. And also, if you take your coil up and put it sideways and it gets noisy, that'll be EMI. So EMI, left and right, front and back, whichever way you want to orientate your coil, and straight up and down on the ground, if you get an increase, that's solar. So, and also, I should say that you have that earth return power system out in the country as well. Sometimes that is putting a signal, well, basically 50 hertz through the ground. And just the way that works, you're having your coil flat in the ground. If you start getting, that woo, 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 so it's the only way I can reproduce it to make the noise, that woo, 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 sound, as your detector heats up and cools down with sunlight on it or whatever, and the frequency changes, usually that's 50 hertz, because these things, they will change frequency as they heat up. The crystals aren't that good. And yeah, and also the transmitter receiver section is an LC oscillator in these. So the coil gets hot, the capacitor gets hot, it will change frequency, and that's when you get that, whoopity whoop whoop drifting sound, especially when you heat your detector up or cool it down. And don't keep it at a constant temperature. If there's interference around it, it'll start doing a beat frequency with the detector. It's only the micro and audio processing chips that are controlled by the crystal in these things. And the rest of it is run off the LC oscillator, which is interesting. Anyway, leave it there. I don't want to go waffling on about detectors. It's I think it makes people's brains turn to liquid and start pouring out their ears after a while. So it's enough of that. But this is a doozy. I definitely can. I've got a couple of set resistors here that are up in the air, or naughty, should be over the ground plane hard, because it's a high impedance point. And I did that basically select on test to balance the two channels. So I've done that. Maybe I could alter that a little bit more. Don't think I really need to. Maybe I just scale both channels on the VGA input and do that, and that'll be done. Anyway, enough said. What a kick-ass detector. I think I'll be keeping this one for myself. This one, because it's mine. I think I might be using this quite a bit. We'll see how we go out in the field anyway. Catches, guys. And that's off. And now turn this off. Catches.